We had rather lot of sessions on modern technologies that can be used on gear manufacturing aspects. We learned or we discussed more on the EVs and modern technologies, and mostly in all of the sessions we had what could be the contributions of AI as emerging technologies in the manufacturing of the gears. But nevertheless, to make it simple at the end of the summit, I am keeping my topic simple but practical and quite educative. I think in the audience who are new in gear manufacturing, I'm sure they will benefit a lot from the presentation. To many of them it could appear it's simple, but yes, the reason why I have chosen these slides is that it's based on my experience that the gear manufacturing companies still need to gear up for the slides or whatever the important aspects in gear manufacturing is, by which, though they are traditional, we can really make gears efficient. So that's the idea. So let us see one by one the slides, and whatever the questions you have, please ask. I'm ready for any questions to answer you satisfactorily. Okay? So generally in gear manufacturing process, normally we have to have focus on certain processes which comprise till the manufacturing of the gears. So basic subtopics could be like the input condition, the blanking. Okay? The second could be like the selection of toolings, the mounting of tooling on the machines, the fixtures, the cutting parameters, and certain strategies of using the tools respectively. So we will see these topics one by one and how it really matters, though they look simple, but if we strictly follow them in industries, they will definitely cut down your cost, and we can see that it is really efficiently we can cut the gears. Really, as means in the sense of keeping the tool cost piece and the machining cost per piece as low as possible and as predicted as possible. Okay? So we can avoid the hidden rework in the gear manufacturing processes. Now we all know the blanking, the gear blanking is very important operations. We have to offer gear blanks for cutting gears as precisely as it should be for the machining of the gears. Either it could be gear hobbing, gear shaping, or gear broaching, many other cutting processes. So you can see there are two kinds of components. One are the rotational parts, the other are the prismatic components. The rotational parts mainly comprise the disc type and the shaft type. And these are the parts which really come into the gear manufacturing processes. The other parts, prismatic, they go for machining center applications. Okay, like gearbox housing and etc., like cylinder blocks and cylinder heads. So we'll focus mostly on the disc type and the shaft type components. So the blanking of the gears has to be very, very good. So we need to pay a lot of attention and focus, but mostly we find ignorance and they are ignored in the flow of manufacturing process. Now we have here bow type components. We need to focus at the beginning. We need to plan what are the resting phases or the references that will be covered or that should be taken for the gear manufacturing process. That has to be planned at the beginning only, not at the level of gear manufacturing process, because gear manufacturing comes at the end of the flow of the component. First is always the blanking, then it might go on the VMCs or the HMCs, and then it go on certain operations, then it comes for the gear cutting machines. By that time, lot of operations have been done on the component, and we have make the component expensive rather. So we can't afford to lose the component in the gear process, because all the operations done in the previous stages, they will go wastage. So thus the blanking is very important. Now this slide shows that if we plan the resting and the reference location in advance, we have to have maintained their squareness and perpendicularity at the initial stage only. So this is very important for blanking purpose. Plan it, you after doing parting operations of the ingot, offer it to the lathe machines and educate the operator that the face and the bore has to be done in one setup because then and then only the squareness will be maintained. And that face and that bore has to be considered as reference purpose in the machining of the gears. Okay? This is for the bore type component. Similarly, for the shaft type component, it is very important that we do the facing and centering of the component at the initial stage. Okay, either it could be forging or it could be a shaft type component cut into. Because if we do the facing and centering very accurately, then they form the basis of reference for every further operations in the cycle. Okay, when it take for turning, for grinding, for gear cutting, for VMC operations. So those references remain constants. And when the references are constant, then all in the machining process, the accuracy achievement plus the inspection references being common, we achieve correct levels. We can rely on the results of the inspection. That is very good purpose. What happens generally, shaft type components, they are done in two setups. The centers are formed in two setups. The centers are never coaxial, believe me. So there has to be centers formed at the initial stage only. Many industries do not have good quality of facing and centering machine for shaft type components. I suggest they should invest in those machines. Nowadays, those machines also in CNC are available, facing and centering, doing batch production immediately. So when we do that facing and centering operations, we can rely on the references for further operations in the flow. Now, we need to have a reference diameter for the holding of the component. Even that diameter has to be coaxial and concentric with the axis formed by the centers of the component. So that is also very important. So all these processes we need to plan in advance so that no mistakes are made. Otherwise, means, you know, they are likely to have rejection of the components. Now the question is how we are going to turn long components in single setup. In lathe machines, we can have a face driver fixtures on the chuck side. Three jaws can hold the self-centering jaws can hold the component in the center between location, and there could be a face driver for driving or jaws, either of these. With that, driving can be done, and throughout the length of the component, a turning can be obtained. If required, you can have additional stage, doesn't matter, but it gives satisfactory results. Followed? So it is very important in the blanking operations to pay attention. Now these references, what are they? Suppose for a bore type component, they are the axial face surface and the radial reference surface. We have to check the runouts with dial indicators, and we should see that they are being maintained. Now how we are going to check the diameters? We can hold this bore type component in between center, bench center on a taper mandrel through one face, and you can check the axial runout of face 1 so that we can assure that the face and the bore has been machined. So that's how it becomes of importance. If we don't pay attention here, then we struggle at the end why this lead accuracy is gone out, why this profile accuracy is gone out, the runout is not coming, and all then we start back working. We have to need to stop. Now my point here is that many industries have the data, they have the knowledge, but a kind of lethargy, I may say so, or some ignorance is there, or some assumption is there, because they feel when the drawings are done, they should be done at the various stages of machining. But when it comes to the component at the batch for the gear cutting, you find sometimes a batch is rejected, or sometimes many components are not adhering to the requirements of gear blanking. So that's the importance. So we have to maintain this. We have to pay attention. Now it so happens in certain companies the blanking operation is given to the vendor, and the vendor turns the component and comes to the company. They are neither checked, neither the vendor has the knowledge of importance of geometrical accuracies required for gear blanking. So that's the thing, one observation is there. The components coming from the vendor after GRN, they are directly going to the gear cutting applications, because pre-machine turning is all done at the vendor. The vendor doesn't pay any attention to the geometrical accuracies, and then the problem arises. So if it is a vendor registered, he should be educated for maintaining the accuracies of the gear blanking. And he should be trained and he should be given a complete drawing of gear machining as it is presented to the machine. He must be asked to pay the focus on this particular aspect while finishing the turning component before offering it for gear cutting. That is very important thing. Okay? Now all these geometrical accuracies, if are maintained, then we are sure to get gear accuracies in first pre-pack condition or initial conditions very good. There will be very little rejection and all parameters, about at least 10 parameters of gear accuracy will get correct. So that was about the input condition. Let me tell you, due to wrong input conditions, many companies don't really follow strictly. The accuracies or inaccuracies what we get in gear, we can attribute it to at least 50% because of the incorrect input condition of the component. As it is required, it is not there. Nowadays we have good CNC machines, lathe machines, they can produce good components, but just because the drawings are not prepared properly, the understanding level at the requirement of gear cutting is not there with the CNC supervisor, the attention is not paid much, and therefore the problems arises over here. This is still happening in many industries. I cannot mention the names, but even tier 1 industries also it is happening. I am visiting even now. Despite of so much knowledge everywhere, everybody is having, still it is not strictly followed. That is my sure observation. So now let us, when the new component is to be done, how to select the hop. Certain guidelines I have given. It doesn't cover everything, okay? But certain important guidelines like number of start, maximum module, minimum number of teeth. This is one chart, selection of gashes, okay? We all know that if we have more number of gashes, we are going to get good profile, good involute. But really, if what happens with, if the number of start increases, or what happens with if the number of gashes are not adequate. So all this we should know. Now in types of hop selection, especially for gear hobbing operation, if the hop diameter is small, for a given cutting speed, the RPM of the hop increases. If the revolution of the hop increases, because of the index ratio, the table RPM increases, therefore feed mm per minute increases, and thereby we get a good cycle time. Now it is not mandatory nowadays to use the catalog items for selection hops. The hops selection, the hop manufacturer might tell you, you can go into the catalog and select the hops. It is not mandatory. You can decide your hop specifications on your own by virtue of your experience. Decide the diameter, decide the bore diameter, decide the number of gashes, decide the length of the hop. The longer the hop, better the tool cost per piece, better the utilization. If your machine can accommodate longer hops, it is better to decide for longer hops. Catalogs may not give longer hops, okay? Extra long hops, it will be more, less costly, but marginal cost you can put and buy the hops. So optimum length, gashes, start, diameters, considering productivity, quality, and tool cost per piece. So these are the most important things you should consider in deciding the hop cutters, okay? Now what are the cycle time reduction strategies? Whatever the points we have mentioned, suppose if we plan it accordingly at the initial stage, we really get good gears. So higher speed feeds, okay, we all know, we discussed this, that smaller hops give higher RPM and thereby lower cycle time for a given velocity or the surface speed of the hop. Second point is multi-start hops. They also bring down the cycle time, but of course they result in a bit inferior quality as compared to single start, and we should judge whether that quality is acceptable, or if that quality is obtained, can we make it superior in our post-finishing operations, post-heat treatment operations. So accordingly, taking a fair judgment, we can do the selection of the hop. The third is the optimized cutting parameters, speed, print, and feeds. So if we take a powder metallurgical hops as compared to HSS, we can apply more cutting speeds and thereby reduce the cycle time. But PM hobs are costlier hobs as compared to M35 or M42 HSS hobs. Followed? Now this is about the multi-start hob advantages, what we get. Single start hobs, we all know how it works, and the multi-start hob, how it works. So these are the other things like additional productivity boosters. We can load multiple workpieces on the hobbing machine if possible. If it is permitted, by all means, we should opt that choice. We should go for it, okay? Then automatic workload station, okay, we can have automation for the machine, double gripper type autoloader or indexing type autoloader. But of course, it calls for investment, then its technology, plus its working, it should be known to the operator, to the supervisor, how it works. And nowadays, it has a lot of electronic content. So therefore, its electronic knowledge also has to be there. The industry must have. The time should not come when automation is implemented, that for any small and problems, you call the supplier. You take a phone and call the supplier. That time should not come. The industry should be geared up for that technology. Whatever it is acquired, it should be digested. Okay? Otherwise, I'll tell you one thing. In automation, some companies, big companies, tier 1, they may not prefer automation. They have a takt time of 1 minute. An operator, I have seen personally, it's a beautiful arrangement. There are 4 machines, similar machines. The operator can reach all 4 machines. They are arranged in such a way that 2 machines face each other. And then in one takt, meaning that is in 1 minute on 4 machines, he gets 4 components. So how he manages? He just loads, unloads by man so quickly. The door closes automatically and door opens automatically also. The component is just picks up and put the board type component by hand, and as he passes on to the next machine, as he walks to the next machine, he just, one lever is there, he just taps that lever and the cycle starts. In that cycle start, the door will close, the job will get clamped and cutting will start. Then he goes to the next machine. Similarly, he does on the second machine, third machine. He keeps on moving in this way. So that's a beautiful arrangement. I don't think any further automation will work better than this. Only human fatigue is there, I understand. But that person is highly motivated. And you know, sometimes we have to see that jobs are also given to the people. So from that perspective, this is a good arrangement. So tier 1 company employs this kind of arrangement. I'll mention the name of the company, it is TVS, Hosu. So nice arrangement they have. They have highly motivated operators, low educated, given the job, trained very well, and they operate such machines. So automation high end, okay, some people might require it, but some people can do without it also. Now another important aspect I was mentioning, that work setup. This is the topic which I want to emphasize, is that not much attention is paid. Only by the companies which are engaged in the manufacturing of fixtures, or by companies who really are finding it very important or doing it. Many companies tier 2, 3 onwards, they make some, make to shift arrangement for fixturing and they manage to cut gears. But they kill the principles of fixturing and, means it is not very good to skip it. Okay? So there are some guidelines, there are some principles, how the work holding fixtures for the components can be designed, developed. It is mandatory. It is good to invest money in fixtures. If you have many batch or family of components, you should make a first initial study. For which components I can have resting body common, for which components I can have clamp common, for which components have, how many components I can have location commons. We can make a beautiful chart, and commonization of elements of fixture can be made, okay, in an industry. We all know this in advance. We all know how many components we are going to machine. But seldom such collective attention is paid while designing the fixture. If we pay that action, then principles of fixture designing are also maintained, plus cost cutting is also maintained. We can have a beautiful chart, pass it down to the line manager, to the operator, and explain him this is how the elements of the fixture to be used, and accordingly the system will be work very nicely, effectively. Okay? Many times I see that the resting body or the component rests very near to the bore of the component, though it is large in diameter. It is never resting near to the root of the gear. The company which I was working, we had a very strict decision. All components to be rested near to the root diameter, just 1 millimeter away radially. We are cutting gears on CNC machines. There is no fear that hop will come and dash the fixture. So the component has to be rested near to the workpiece, near to the root diameter as far as possible. Even the clamping also has to be there near to the root diameter. That is how it should work. Then the fixture should have a good shape. It should have a taper shape. I mean to say, I will show you some slides, fixture layouts I have. So that's a very good designing of fixtures. These are the fixture layouts. You can see, I have taken an example of bow type components and shaft type component. See the concept, and this is a face drive fixture for the shaft type component. It's a bull pinion shaft. It's a face drive type fixture. Now you can see in the layout of the fixture how well it is informative. And this task is to be done by the manufacturing engineering department at the top, by the work holding team. You see the distances, the hop diameters, the gear parameters, the location diameters, the tailstock support, okay? See the concept of fixture. It is beautifully well explained. No doubt it takes time, it takes pains, it takes cost, but company has to invest it. Companies generally shy away, feel unnecessary, ignore it, but that's not the thing they should do it. Managing some bushes or some fixture elements and try to cut the gear is not a good idea. You will never get good accuracy. Then you will struggle it later, try to improve the fixtures and all. Okay, see these bow type components. It's a simple mechanic, hydraulic operated fixture, this component. It's a double loading, there's a spacer in between. I hope you see the spacer in between. It is this fixture was supplied by Premier to Brazil, Deco company. And see the concept. The machine is simple, the fixture is simple, but the compliance of principle for the fixture designing are met. That is the importance. And that is what I call the efficiency. See, these are all traditional ways, but are we complying it? Are we maintaining it? That is more important to the industries. And I find it lacking. I am moving to many industries in India and I find it lacking, sorry to say. So there is a lot of scope in improvement and understanding this. Okay? When the fixtures are good, then whatever the theoretically we say, oh, this cutting parameter, this speed, this cutting load, it should get applied. It will definitely get applied, provided we design and develop good fixtures. Now see, here is an example of component stacking. See, here we give the resting and clamping near the root diameter of the component, okay? These could be sprockets, I guess so, sprocket component for two-wheelers like front wheel, rear wheel, or some starter gears, starter ring gears, okay? Starter ring gears are one of the component where multiple stacking is done, like 30 to 40 components are stacked in one fixture. But the beauty lies in the shape of the fixture of outline, nowhere compromise of the material, nowhere purpose is diluted, and proper design is taken. This simple mechanical fixtures but hydraulically clamped. You can see the location and the clamping rod, they are separated here. There is no interference of location and the clamping. Most of the times it so happens the drawbar which is responsible for clamping, the same drawbar is used for location. It's not you can't give two functions to one element. It is a wrong idea. We have to separate the two functions clearly, and we should see that every element has one function and they operate sequentially and do the fixturing. Okay, you see the clamp. It is easy, just rotate it 30 degrees and remove it. If it gets heavier, you have some lifting arrangement for the clamp. And all components can be taken out by hand. You can ask the operator to wear the gloves and he can remove the components, all 10, 12 components aside. I don't load another 10, 12 components. At the same time, if we have to have automation, we can have a stack ready of 10 components and replace it. That's also possible. But many things are possible to do in an industry where we need to do it. Now, these are the advantages of stacked workpieces. Then multi-start hobbing advantage, we discussed about this. Okay? So if you have any questions, please ask, because I'm more interested in questions to answer. My topic is very simple, but I find it is not followed strictly in India. I make this statement based on my lot of visits to all industries. And this is one of the efficient way of manufacturing the gears. Before we talk about AI and emerging technologies, are we qualified? Are we doing this? So we should all industries, all persons should ask themselves. Now let us say the hob setup methods. See, many industries, they don't have like, just mount the hobs and automatically will get the runout on the hobs, on both the collars. We have to check it, okay? We all know the results, what will happen if the hob runout is not good. So there are some guidelines of how to mount the hob, locating the hob, shifting of the hob. So all these strategies one should understand. Mounting the hobs, there has to be 2 collars at the end. Many tool manufacturers don't give collars. We have to ask them to supply collars at least 4 to 5 millimeter width so that we can apply dial for checking. Okay, that's very important. Now we don't want to do this job on the machine because machine downtime increase, we can have a tackle outside. We can do it on the tackle, which is similar arrangement like on the machine. But yes, this activity is necessary to obtain good profile primarily, and of course other accuracies. Okay? So the idea is that the important aspect when we through the hob, I think it's on the next slide, the 2 collars, the high point of the runout should be lie within 30 degrees. It's not that suppose I get 6 micron here on this collar and this high point and the other collar has high point on the bottom side. It's 180 degree opposite. It's not acceptable. It should lie within the 30 degrees. So then you can expect good accuracies. Followed? At times I have seen practically that the other end of the hob, where the operator is standing, that is not accessible. It is difficult to apply the dial indicator. Then he ignores it. And after cutting the gear, he rushes to the boss or the line supervisor that the profile is not coming. Because he checked the runout on the collar on the that hob portion which was accessible and visible to him. The spacers, they didn't allow him to apply dial also. The spacer diameters behind that hob on the other side, there has to be appropriate diameters, if at all there are spacers. So there are many things we should consider where important, and this knowledge is available, but problem is implementation. I feel sorry, miss, why it is not implemented? It needs to be educated all the time. So care has to be taken. Now who should take the care? It should be taken by the work holding fixture designer or the arbor designer or the process planner at the top in the office. And therefore sometimes I feel the person at the top has to have certain practical exposure to the gear manufacturing aspects. Theoretical knowledge won't pay anything at all. It won't be beneficial. Okay? Many times the hobs, one of my friends is doing sharpening and coating in Pune. He comes, he finds the hob is worn out at certain portion only, not worn out. He can come to know. But he has to sharpen the full hob. Okay? Then what happens? By this, the amount of sharpening increases and number of resharpenings goes down. Then you have to throw the hob quickly. Then there is no fun in that. You are incurring the cost. You are operating a hidden factory of losses, knowingly or unknowingly, just because of the pressure of the management, just because of the pressure of the workload. There has to be a systematic approach. Okay? Now this is about the shifting strategy, how you should shift the hob. Now this is okay, this we understand. Now what here I would like to explain is that please adopt shifting strategy. It doesn't matter if your batch size is all. What normally I see is that people have the tendency, the operator, to cut 10 jobs at one position and then they shift the hob. Maybe as per their wish. They have no base for that. 10 millimeter or 1 pitch or 5 millimeter and they cut another 10 jobs. Then they come to me. When I shift the hob, I don't get the size of the gear. How will you get the size of the gear? Because you had adjusted the size for the 10th piece on a given position, and on the fresh position, it's a fresh teeth. Definitely in terms of micron, it is a plus. So you'll get an undersized job. So you should have a shifting strategy in such a way that for every workpiece, the hop is shifted. Don't avoid, after establishing the cycle for 2-3 pieces, go for hop shifting. Never avoid hop shifting. Doesn't matter how small your batch size is. Okay, that's very important. What happens with this? This literature is available in all textbooks, but importantly is, no literature says use hop shifting for every job. I am saying that. So you need to follow it. There's one simple formula here, what could be the hop shifting amount. But yes, there are many methods or many formulas. I have taken only one over here, hop shifting amount. So at least you can think of bringing at least one fresh tooth of the hop for the next cycle. With that, this formula will help you to decide the amount of shifting. And now that shifting amount you can quickly give on CNC machines. It is now infinitely variable. The least count is 1 micron for the y-axis, okay? So that's not a big point. You have the machine which is capable of hop shifting 1 micron, then why don't you use it? Okay, don't use CNC machine like conventional machine. Conventional machine, it has a fixed hop shifting amount. Okay, it's difficult to adjust. Nowadays, that technology, most of us, we find it unacceptable since we have the neo technology. But when we have a neo technology, we should not shy away from using it the way it should be. That's my point. But seldom I see in tier 2, tier 3, tier 4 companies. See, there's one statement here, the hop change should not occur in the middle of the shift. Then it kills your production time. When you have gathered experience, like many people have talked about data capturing and all those things, okay. Means industry knows, or rather the person behind this production knows after how many thousands of components or hundreds of components the hop is going to shift, and at what time the shifting will end. Okay, it can be one passes or multiple passes of the hop, but hop is going to end one shifting. But that should not happen. He should plan the hop shifting and strategy based on cycle time in such a way that hop shifting comes at the end of the shift or at the beginning of the shift. And again, I'm telling you, the only company I saw this using is TVS. I moved many companies, about 150 companies I must have moved in India on gear cutting. But only TVS I found, I appreciate. I remember one, Mr. Natarajan was there, and he used to educate the people and take the, this wonderful, I see. I don't see in any other reputed companies this kind of thinking philosophy. Even in that company, I found the hop shifting range, the Y1 coordinate to Y2 coordinate, it is determined by a hop centering device on CNC machine. Using it, writing those values, putting input in the input menu of the dialog program and using it. So that is the systematic approach. What harm is there? How much time it takes? Nothing. But seldom people follow it. And therefore, at times, I don't approve personally of AI talking. We have to graduate first. See, the material removal after heat treatment is costlier. So grinding operations are costlier than hobbing or shaping operations. So it is very much expected that the grinding operations, the allowance must be kept less. So we have to do efficiently the pre-heat hobbing or shaping operations, okay? Then other aspects of doing fast operations are like using carbide tools, dry cutting. This is the simple chart. You can just have a look at it and you can ask me questions. This first column is important. Input workpiece requirements and modern tool design. The rest care is taken by the machines. In process planning, this first column is important. Let me tell you, the selection of hob nowadays is to be done by the user, not by the hob supplier. I never did selection of the hobs from the catalog of the hob supplier. Could it be foreign parties or could it be Indian parties? I dictate my own terms in designing and development of the hobs required for the component. I tell my customers also. And accordingly, the hob manufacturer develops the hob and pays it. He might argue that I will ask for you better price or higher price because it's not a catalog item. It's okay. Ultimately, you are going to benefit more than not he. Okay? So that's important. Pay attention to this. It's very important. Now see, how to determine the shiftable, this was one exercise done to Sanjeev Auto, the shiftable range. If you have a hob, you have to place the hob on the arbor so that shiftable range is fully utilized. You can't place hob at one end. Many people find it, oh, I don't have spacers, he takes it to one end or the counter-bearing end. He should place it in between. And accordingly, how much is the shiftable range? We can calculate and find out. This was done on CAD, but it's okay. We can do it by calculations also, no issues, by tool room method. This is the hob shifting strategy, one diagram. It's very clear, it's self-explanatory. In one of the slides, I forgot to point out one thing in input condition cases or the work holding fixtures. That was, I also find many industries do not comply to the principle of holding component for inspection purpose. That's very, I forgot this point to mention in input condition we were dealing. See, the way the component is held, the way the references are considered, those references must be also considered for holding the component in the gear inspection room. It should not be different. Then you get different results. Then there's an argument between inspection department and the production department. Then I have to come and solve it. So that also care has to be taken. It doesn't mean that if you buy sophisticated equipment like mandrels from outside parties, jelly-filled mandrels or zero, they will really be reliable or you ought to believe them. No, it's not like that. To me, if you ask me, the best mandrel is the taper mandrel. A 20 micron taper is the best mandrel. You put the bow type component through one phase, that will give the best result and or result near to the what it should be. Because on the machine, when we cut gear, the resting phase was resting. We trued that phase on the taper mandrel, and definitely the bore which was machined with square to the face in the turning machine will be square in the inspection room, and therefore the results are reliable. But nowadays nobody has taper mandrels also, okay? So, but foreign makes mandrels are available. Don't do that. Go by first principle for engineering. When you have a learning phase, when you have an establishing phase, go by first principle of tool room method. That's the best way. No other way can replace it. So that is what my point. The inspection reference must be common or exactly same like machining reference. This is one statement which many companies do not follow by virtue of facilities not available in the gear inspection room. The manufacturing engineering person who is responsible for all these stages of operation must think on, if required, he has to develop a fixture for inspection room for a given, he has to spend money. He should not think of saving the cost. Mostly the attitude is of saving the cost. Many people might know, or they are knowing it, but they save the cost, they try to manage. If you have hold a component for cutting between center and just the bottom end you are holding the chuck in gear inspection, how can you expect the good results on gear tester? It's just not possible, and that is what people do. And in good companies they do it. That is still saddening to me. So this could be a repetition, means higher speeds and feeds we have to adopt for cutting down the cycle time. How a multi-start hob reduce the cycle time. We have this all literature in the books or nowadays on the net also. But the point is, it needs to be implemented. The point is, it needs to be thought of. The point is, it should be thought of well in the advance while developing new part on the machine. That's my point. Therefore, I'm covering these topics. It's not that the audience might not be knowing it. They might be knowing it. But implementation, when it comes, I'll tell you, poor. So guidelines for cutting speed. These are just the guidelines, not hard and fast. Might be old now. We could have faster speeds and feeds. See, the second statement, for coated hobs, the speeds can be increased to 10 to 15%. I'll tell you, many companies, when they buy the hob from the hob supplier, they are coated, Alcona coated or tin coated. When they use it and we offer for sharpening, many people say it is not need to coat. Why? You can see the hob still looks yellow and gray. My dear, the face, the rake face of the cutting face, it has lost the coating due to sharpening, and therefore, if you ask me, it is an uncoated hob. It is an uncoated hob. That kind of education I have to give to the established gear manufacturers, tier 3 and tier 4. So, please, when you resharpen the hob, don't shy away from spending money on coating the hobs. Don't save money. Such saving is not useful. By saving, such money is not. If you coat the hobs, then what you are going to get by coating the hobs, you pay attention on that. And the benefit what you draw is more than what you spend on coating the hob. So, talking of great things, what Western countries are doing, what other things, are we doing what we have been educated? That's the important thing. Followed? This is about the cutting feeds. See, in terms of cutting speed, it's the only industry experience what we have to settle with. Take a lot of trials based on cutting tool material, the workpiece material, their hardness, their homogeneity of material, the type of tool, the coating. Many parameters are there, hundreds of parameters. I must not have listed here, but I am aware of. So best way is quickly you should assess based on certain theories, based on past experience and what the current machining trials would offer you, quickly establish it and document it. So that's the best way, provided you are getting the desired accuracies. That's the way you should follow. There is no hard and fast, there is no written book that such feeds and such speeds to be applied. No. The last line is important. How the feed decreases for the multi-start hob, we all know the reasons for that. If a multi-start hob, you can apply the same feed as the single-start hob. Okay, the tooth load increases drastically. Now, certain gears, this type components are there. At times, we would prefer them to cut on gear shaping machine instead of gear hobbing. When thin this type components are there, and it is compulsion to cut only single piece at a time, why don't we cut in gear shaping instead of gear hobbing? Because in gear hobbing, we do approach of the hob. The cycle time is larger. So we might get good productivity on gear shaping machine. So shift those components deliberately on gear shaping machine from gear hobbing machine. So that's the idea. So that thinking process has to be there. Now we'll go to certain modern things. After discussing all the traditional ways of efficiently cutting the gears, some of the parameters I have taken like input condition, cutting speed feeds, hob shifting, selection of the hob. There are many more parameters. I am not touching them here because of the paucity of the time. But before we move off, I hope any questions are there on the traditional ways or...
Hello. What I wanted to say is, in the hob shifting, you explained very well, but the purpose of hob shifting is to distribute the wear on the hob.
Yes.
If that's the main purpose.
Exactly.
The wear distribution must be even on the hob rack length. So the interval of shift becomes necessary.
Yes, exactly.
And if you come back to the starting point, you create an offset in that,
exactly,
which is sometimes necessary in HSS coated hobs.
Yeah.
Then you can improve the hob life. And in carbide hobbing, you go by shift per pitch, because that function is what you explained. Normal module Z1 into pi divided by cos gamma into multiple number of gashes, which is nothing but a lead function. Okay. It's a lead. So if it is pitch multiplied by number of starts becomes a lead. So that equation is nothing but the lead of the hob, which is segmented into shift length. Okay. That's good. It's given in the Hurth book also. Okay. But the point is, this is a good practice. If you shift in that way, then the involute discrepancy is the word which we say when the involute error is coming out the tip side. So you will retain the position of the involute deviation over all parts if you shift the hob in the equidistant way. This is good for gear shaving. It is a necessity in gear shaving, in plunge shaving, to shift it uniformly, but otherwise not.
But in this case, it is a module multiplied by pi. That is
module normal module pi number of hob starts divided by number of gashes into cos gamma. So the lead angle. That's a lead function actually.
That's the lead function.
Z1 is deviating.
Okay. Okay.
So in that one, this becomes necessary if you do pre-shave hobbing. After if you shave it, it gives you the correct position of involute arc on the tangents on all the batches. If you shift indiscriminately differently, that changes. Sometimes when the shaving cutter starts sitting at the peak of the load, it may change the deviation. That differences it gives in involute, you will not be able to rectify in remainder of the strokes. So that was an essential thing as a necessity. I just wanted to touch that. Otherwise, the distribution of wear will give you good parts without any stress limit on the component.
Thank you, sir. Thank you very much. I have few 7-8 slides related to the emerging technologies or where we can think of applying AI for the gear manufacturing process. But yes, we can just, the things are coming up. Last year I saw at IMTEX many IoTs companies have come up with certain methodologies how we can go forward on this matter. So the precision gap is there, of course. This aspect is very good, total cost of ownership. Instead of looking for cost per part, if you look for life cycle value, reducing the scrap rates and energy consumption. So here I would like to just give an example. One industry, what they did do, they have a gear shop. They have a controlled environment. Okay, it's an air-conditioned gear manufacturing shop for the aerospace company. Now, the coolant gets heated up and the control panel gets heated up, then the heat comes out, there is a AC for the control panel, and the hot air comes out. Now the hot air comes out, and if they are left open in the shop, then we have an AC shop, then what's the usage? There is a load on the AC. So they are collecting from every machine in the bay with some kind of mechanism, and they pass it on to the thermal insulated tubes and taken it to the outside, such that the heat generated by every machine, it is taken up to the top when their common channel is there, and it takes out. So that heat doesn't, cause the load on the AC of the shop floor. So that activity they have done it. So that was a nice thing. I could get an example. So the efficiency of modern gears, we are actually, this advanced machining we have already adopted. Many people are now also trying to use power skiving operation for rapid internal gear production. Metallurgy and surface, okay, the material is getting improved. Light, it should be lighter especially. Digital thread, the feedback systems, IoT enabled. Lean process agility. This single minute exchange of die, the SMAD is very important in automotive industries where wastage of time has to be reduced. So slowly many companies are trying to adopt these pillars. These IoT enabled machines providing real-time feedback on tool wear and vibrations. So there are many equipments in the market, like one of them is Montronics. You put a sensor to the hob and they measure the current and voltage in real time. If there is, it's a teach-in method. We first teach in what voltage and what current it should work on. And if there is an increase, it gives a message. Yellow, first yellow message, then red message. I have seen that. And then there's an alarming situation. So has the hob tooth broken out? Why the load has increased? Has the workpiece hardness has increased suddenly on that matter? So that's the point. This power skiving, gear grinding nowadays has become necessary for the quality of gears. Everybody is demanding better qualities, ground qualities. These machines adjust to feed rates to extend tool life until scheduled maintenance. Such topics will come up as AI implementation. That's a very good thing. See, giving offset for size correction. Okay, if there is a failure of coolant, if there is emergency retraction needed for any cause of failure, okay, or something like we have to extend the tool life. Now every gear cutting machine has thermal deflection. If you want to address thermal deflection, which affects the size of the gear, all these parameters I think can be controlled through AI. Nowadays, since we have AI, this could be an emerging technologies. Well, in yesteryears we could do this, but of course with some other methodologies, it was uncommon and industry-based, industry-related only. Then bringing most of the related operations, allied operations together, we have cells, robotic cells, okay? So that the components don't move long from one operation to another operation. this is a real headache. Takt time integration, align production rate exactly with customer demand to eliminate overproduction. It's not a good idea to keep it produced and have finished inventory and expect that customer will order. What happens if it doesn't order? So that's not a, but you should gear up to meet his demand on a pre-decided schedule. That's the important aspect. This synchronized inspection can also be happen on machines with emerging technologies. Especially the foremost, what I would say, is for the size correction. Many people struggle to establish initially the size of the gear, the span measurement or the DOP measurement. It's not, it takes time. So, hoping that machine is all right, the process should be controlled in such a way that it takes minimum time to establish the size. That's the idea. Closed loop manufacturing, I think we discussed in some another sessions also. This is a wonderful idea. Okay? NVH analysis, coordinate measuring machines, real-time SPC. Real-time SPC is very wonderful idea. I have not seen in any industry in India. I'll tell you one example. I was in Getrack Ford Ganzhou plant in China. They manufactured 6,600,000 gearboxes per annum. Each gearbox has 18 gears. So 6 multiplied by 18, so many gears were produced in the one shed. Right from, okay, forging was done at one end only, not in that shed, but forging and facing centering or some pre-operations. The whole one shed it was brought. And there were hundreds of operators, machine operators, and 50% boys and 50% girls almost equally. Very knowledgeable. I spoke to them. What I found there was this closed loop manufacturing. See, every station in gear manufacturing sale, they had a computer nearby. The CPU was here, the screen about 25 inch or 32 inch, I would say. And that operator, what they used to do, as the gear is produced, they keep it on the tackle, it measures the size, the feedback is given by the wire connected to the CPU, the display used to come, what is the side of the gear, then she used to press one button. I asked, why you press for? Then that feedback goes to the CNC, then why do you require now only? Because after 50 jobs, I get CPCPK. And my goodness, I have never seen this idea any time before. Not ever in one. I was so amazed, and I took that subject to the top management of the Getrack Ford. I really appreciated that. Why we have to go for CPCPK to some other department, take time? Whenever she wants, she has a doubt, she just takes the 50 batch. It's a continuous production. 6 lakhs into 18, so many gears are produced per year. It's a continuous project, day and night. And any moment they have a schedule to take CPCPK. It's a wonderful idea. Over there only, she has tackles, every station has mic, everything is there. No talking, no moving, nothing. Only lunchtime. And they manage it very well. It's a wonderful idea. We should at least develop that idea, spend money. Companies are, the operator, let operator be responsible for that. Why it has to be taken to other? Only for lead and profile checking, the gear goes to the inspection. And that also she takes it there by herself, not given to others. A good amount of automation plus over and over this process. Closed loop manufacturing. But responsibility and ownership to that extent to the operator, never seen anywhere. These are all futuristic, or maybe now the ideas, we need to implement it. A cobot and human AI collaboration, I just got this slide, but it's a very long way to come to this stage, okay? So, I thought of incorporating these slides because many would be interested in knowing what is going to happen in future. But I'm worried what is happening now, always. Thank you. Thank you very much for your attention.
Thank you. Thank you so much. I think you've been with us all day today giving your insights, and we truly appreciate your time. I think right from an open panel discussion to such technicalities, we couldn't have better than this from you. So thank you. Thank you so much for joining us once again. So that brings us to the end of the Gear Technology India Summit 2026. But I think this is only the beginning for much more discussions and much more changes to come about in the gear manufacturing industry. We will soon be announcing dates for our next summit as well, and a lot more updates. So keep following us on LinkedIn and you will know about it all. So having said that, we'll sign out now. Have a great evening. Continue to see our exhibition space. Thank you so much.